I think we're all familiar with the Santa Ana winds by now, a local Southern California weather phenomenon. You've got a lot to talk about.
It's been in the news of these devastating California wildfires, and I'm going to go into the meteorology behind what has fanned the flames. The exact cause of the fires isn't clear yet, but we do know that the very strong and dry winds help to fan those flames and spread these wildfires rapidly into tens of thousands of acres that have burned now across Southern California. More Santa Ana wind events have been ongoing after January 7th, when most of these big wildfires started, and more Santa Ana wind events might be coming in the coming weeks. But for now, we have a red flag warning in place for most of Southern California. The update on the two largest fires, the Palisades fire, is over 23,000 acres burned, 19% contained, and the Eaton fire, 14,000 acres plus burned, and 45% containment on that one near Pasadena. But looking at the wind speeds right now, because there are still Santa Ana winds ongoing, maybe not as strong as last week, but this is a good setup to explain what has been happening in Southern California over the past week and a half. So you have higher pressure over the deserts, and these are higher elevations as well. That air wants to flow to the lower pressure and the lower elevations near the coast, and all of that gets funneled over the high mountain ranges along the Southern California coast. And specifically focusing on the Los Angeles area, you have these canyons and valleys where the winds are funneled through, and that accelerates the winds further. But in some cases, like we've seen over the past week, those winds can crest some of the big mountain ranges, descend on the downwind side of the mountains, and accelerate those winds as well to create even more dangerous fire weather behavior, like on the Santa Monica Mountains near Santa Monica and Malibu, where the Palisades fire has been burning. The San Gabriel Mountains are even higher near Pasadena to the north and east of Los Angeles. That sometimes blocks these areas from seeing the strongest winds, but that wasn't the case last week. We'll get into that in a couple of minutes. And then some other valleys to the east of Los Angeles can also accelerate those winds and cause for very dry, hot, and fast winds in certain spots across the region. Last week, it was kind of a blanket of extremely high winds in some spots. Right now, it's more regional in those specific valley canyons, and that's more of a typical Santa Ana wind event when you have that cooler and more dense air over the high desert. Overnight temperatures, even now, are in the 20s and 30s this time of year, but that air becomes much warmer with that offshore Santa Ana wind being funneled and being allowed to heat up as it gets closer to specifically the Los Angeles region. The big weather setup is having high pressure over the Great Basin of Nevada and Utah, and with that cool, dry air underneath that high pressure, it's rotating clockwise, and you get that easterly northeast wind to come and descend through the mountain ranges and passes around Los Angeles. So you have that surface high pressure set up over Nevada and Utah, that strong northeast wind funneled towards the lower pressure at the coast, because that's all that wind is, the difference in pressure going from high pressure to low pressure. So winter is cold, dry air is lodged in that bowl of the Great Basin, forming the high pressure that can stay there for weeks on end, like we're seeing here in January. That clockwise moving air wants to escape towards the low pressure off the coast. And you get the downsloping effect, similar to what we get here in North Dakota and over towards Montana with the Chinook winds. Those winds, or the air, is descending from higher elevations to lower elevations. Those air molecules are being compressed and excited, and that means that they warm up and they dry out. So that downsloping wind off the high peaks towards Los Angeles and the coastline allows that air to really heat up and dry out, and those mountain passes can funnel that air to make it even stronger. This is a gap-driven Santa Ana wind event, what we usually see when Santa Ana winds kick in. The flow is partially blocked and channeled through those valleys. Weaker winds are observed in the wake zones, like around Pasadena, but winds can still crest the Santa Monica Mountains over by Malibu. Those peaks are only about 3,000 feet, but they usually don't crest, come over top the San Gabriel Mountains, where those peaks are 6,000 to 10,000 feet high. But what happened last week was a strongly forced Santa Ana wind event. Those winds were able to crest and descend many of the mountains, including the San Gabriel Mountains, and that allowed for the Eaton fire to really explode in coverage around Pasadena. The results that resulted in the very warm and dry high winds in some areas like Pasadena that doesn't usually see the normal gap-driven Santa Ana winds. So it's a big difference here, and when those winds were strongly forced through thousands of feet up in the atmosphere, that allowed them to even crest the San Gabriel Mountains and descend into areas like Pasadena and accelerate as they went from several thousand feet up to only closer to sea level. So you can see on this 3D schematic, those winds were out of the north-northeast from near ground level all the way up to 15,000 plus feet in the atmosphere, and all of that energy was focused on the downsloping winds closer to the Los Angeles basin, creating for 80 to 100 mile per hour winds. We also had the upper level support in the atmosphere. So this is looking at the jet stream right now with the area of high pressure even at that level of the atmosphere, creating for that clockwise flow and the northeasterly wind all the way up through the atmosphere, generating enough energy to come over these mountains and descend into the Los Angeles Valley. So it's just a stark difference in topography that sets this whole thing up and puts it into motion with the San Gabriel Mountains, the Santa Monica Mountains that are transverse range, east-west orientation. Those winds on January 7th when these wildfires broke out were out of the north-northeast and able to crest even those mountains. And there was a cutoff area of low pressure over Baja California that intensified those winds, drawing the cooler high pressure winds, the cooler high pressure air towards the area of low pressure that really heated things up and accelerated those winds as they got closer to the coast. So there's several Santa Ana wind events annually. Each one is different. Some are stronger than others. The strongest on record was in December 2011. The atmospheric setup allowed for Pasadena and Altadena, some areas that were impacted by wildfires right now, to see sustained winds near 100 miles per hour and gusts over 160 miles per hour. So it's the similar atmospheric setup this time, plus it's been exceptionally dry. Only 1/1600th of an inch of rain since May 6th of last year in LA. There was also an interesting fact with those high peaks, the big mountains around LA, creating mountain waves or gravity waves, where there was even more turbulent flow as those winds came over the mountains and towards the Los Angeles basin, and that creates for more erratic winds and can really hinder firefighting operations. They had to take the airplanes out of the air for a period of time with how strong the winds were, and can create for the fires to go in erratic directions at some point. So you grew up in the LA area, Kevin, and you remember just watching those winds ramp up somewhat at random times, but we can predict when those Santa Ana winds will be the strongest now, and it's kind of incredible that all the factors came together to produce those devastating scenes that we've seen.
The technology has changed since I was a kid growing up in the LA basin, but I will say that it was a Santa Ana wind event that got me interested in meteorology. It was really that started it all for me.
Wow. Just
the fascination of what's causing the palm trees or the olive trees to blow around in the front yard. Back in the early 70s when I was like 2, 3, 4 years old, meteorologist ever since, right? Studying weather, I should say, ever since.
So something good came out of it.
Something good came out of it, but it's just unfortunate. Everything has to line up to get an event like this.
Right.
And this kind of event might happen again, looking at the long-term pattern, which is completely unfortunate in what's happening because there's just no moisture, as you mentioned. 1/1600th of an inch,
crazy.
that's nothing.
Yeah.
That's a problem.
All right. Thanks, Jacob.
Yeah,
Appreciate
thank you.
it.
Yeah.